Hi viewers, in this video we're going to talk about a problem in applied electricity, and it's a simple circuit. We have to determine the value of R in this circuit. So in this circuit we have a voltage source which is 10 volts. You have a 2 ohm resistor, a 1 ampere current coming down passing through this 4 ohm resistor. We have 1 ohm and R. So let's see, always you have to introduce a current from the source, that is I. You have to introduce a current I from the source. So when I passes through these two, it will reach this junction, and at this junction it will split into 1 ampere and the rest will also pass through this 1 ohm. So let's assign the one passing through the 1 ohm as I1. So from here we can take loop, that is applying Kirchhoff's voltage law, KVL. So taking a loop here, KVL will say that the sum of all the voltage drops in a loop is equal to the source voltage. So the source voltage in this loop is a 10 volts. So this is our solution. So the source voltage is 10 volts and is equal to the voltage drop across these 2 ohms. That is going to be 2 multiplied by I plus the voltage drop across these 4 ohms, and the current through is 1 ampere. So you are going to get 10 to be equal to 2I plus 4. Now you get 2I to be equal to 6. So our I will be equal to 3 amperes. So you can see that if 3 amperes is reaching this junction and it has splitted into 1 ampere, then the remaining will pass through here, and that is going to be 2 amperes. So our I1, which is 3 minus 1, is equal to 2 amperes. Once we have this, let's see, we now know the current which is passing through this branch where we want to find the R. So if you get a voltage across this branch, then we can find the total resistance after you add the two resistances here and equate to that total resistance. So now what will be the voltage across this branch? Now you know that this branch is parallel to this branch, so the voltage across this branch is the same voltage across this branch. So what is the voltage across this branch? Now we know that in this source here, when the current is passing, it is going to leave a drop here. So the remaining voltage that will be left will be the voltage across this one, plus, or which will be the same as the voltage across this place. So let's see, the voltage drop across the 2 ohms is equal to the 2 ohms multiplied by the current passing through, and the current that was passing through was the I, that is 3 amperes. So this will give us 6 volts. So meaning there is a 10 volt source and it drops 6 volts across the 2 ohms. So there will be 10 minus 6 volts, which is equal to 4 volts, left for the 4 ohms here. And since it is in parallel with this branch, it's the same voltage across. So the voltage across this branch and this branch is the same and is equal to 4 volts. So we now know that the voltage across this branch is 4 volts. We know the current passing through is equal to 2. So our RT is going to be equal to 4 over 2, and that will give me 2 ohms. So since our total resistance here is 2 ohms, we can say that 1 ohm plus the R is equal to 2 ohms, and R is going to give me 1 ohm. This is the end of my video. Thanks for watching. Kindly subscribe and share.